Hello, this is Dr. Lopez. This lecture covers section 4.1 in your textbook. The objectives of this lesson are to help you understand that populations of species are described by density, spatial distribution, and growth rate. First, let's get some background information. A population is defined as a group of organisms, all of the same species, that live in a specific area. A healthy population grows and dies at a steady rate, and the population is affected by a variety of things, including the availability of food, water, space, and then also things such as disease and predators. Now, the population growth follows what's called a J-curve, and you can see this illustrated in the graph above. Population growth starts out slow, since the number of breeding individuals is low, and then, over time, as there are more breeding individuals, the population starts to come up, and that's where you see the J-curve. In this J-curve, there's a rapid period in which you have exponential growth. This begins to form the S-curve, and is where the limiting factors come into play. Things such as lack of space or lack of food may limit growth. The S-curve is where the population starts to stabilize. The number of species that an environment can support indefinitely is called the carrying capacity. Carrying capacity. Carrying capacity equals the number of births and deaths. These can fluctuate above and below the carrying capacity. Events can cause death of populations, such as famine. Something like that can cause a complete catastrophic death of an entire population. Several factors affect an organism's overall life pattern. Organisms that can reproduce rapidly and have more offspring tend to have short lifespans, while the opposite is true for organisms with slow life histories. Creatures such as a whale, which might give birth to one offspring every 1.5 years, tend to have a longer lifespan. However, if something were to happen to the whale's environment, say with hunting or pollution, its numbers would more rapidly decrease and face extinction than that of the mouses. There are three distinct patterns of spacing of a population within an area. The primary factor for dispersion is the availability of resources, such as food and water. Examples of this sort of distribution are illustrated above. Black bear are uniformly distributed, coming together for mating, whereas elephants are clumped, offering protection to their young, and deer tend to be in a random assortment. Populations are affected by limiting factors. These factors include things such as availability of food and water. These things can affect the number of individuals that are able to survive in an area. The density of the population is how closely packed the organisms are. The limiting factors can be both dependent on the density or not dependent on the density. The examples are listed above. Notice that a density-dependent factor, such as HIV or AIDS, can limit the population growth in some areas of the world. A density-independent factor is something such as a volcanic eruption or a tsunami. It really doesn't matter how densely packed you are. If you're in the area, you'll be affected. The interaction among the various populations in an area also limit the population size. Things such as the introduction of a new predator, competition, or overcrowding can limit resources. Remember, life residing in one area is interdependent. Therefore, if one thing is changed in an area, the ripple effect through the populations that reside there could be mild to catastrophic. Understanding the relationships between organisms in an environment is imperative. As a side note, often you'll hear about environmental studies being conducted in an area where construction is taking place. These studies take into consideration what organisms are living in the area and how the construction will affect them. Additionally, you may have traveled to Hawaii or another country where you are asked if you are bringing in any fruits, vegetables, or animals. These questions are to prevent unknown diseases or animals from entering areas where they might have major impacts on the ecosystem. In our next class, we're going to spend time walking around the grounds at Sacred Heart, looking at our own ecosystem and observing how organisms here interact and live. We'll see you then.